Today's video is going to be another video on the Fnirsi IPS 3608 power supply. It appears that this is turning into a bit of a series of videos. I hadn't really intended it to be that way, but I guess that's just how it's working out. So in today's video is in response to the supplementary video that I made on this power supply. If you haven't seen the previous videos on this power supply that I've made, I recommend that you watch those first. This video is a follow-up to the first two videos. In the second short video I made was in response to comments that I had on the first video asking that I do some current plots of the power supply rather than just voltage plots. I kind of misunderstood what I was being asked. The commenter was actually asking me to apply the power to the load while the power supply was already enabled, rather than connecting the load and then enabling the power supply. So in this video I'm going to address that. So let's go. Okay, so what I have here are two 4 ohm 100 watt resistors and one 8 ohm 100 watt resistor, and by using a combination of these three I hope to be able to do both constant current and constant voltage plots on the scope with relation to the power supply. So I think I'll start by doing some constant voltage plots, and then when they're done we'll move on to the constant current ones. So the setup I've got is quite simple. I've got the output from the power supply with using the supplied cables, the red and the black crocodile leads, and I've just got a single scope probe connected here. So I'm using this metal plate as a heat sink. These resistors can get kind of warm, and I've just got some tape on here to stop any short circuits occurring. We'll start with the constant voltage traces. So I've currently got the current limit set to 8.2 amps, which is maximum current. I'm using a 4 watt resistor and the output voltage is currently set to 500 millivolts. And what I'll do is I'll just do 5 traces on each setting, as much as I can. So 1, 2, 3, 4, 5. And let's just reverse the probe, do the contact with the negative terminal. Just hold that down. 1, 2, 3, 4, 5. And let's just do the positive again. 1, 2, 3, 4, 5. They do look a bit different. Fan's just kicked in, so I'm just holding that on, and then I'll take it off, hold it on, oops, take it off, hold it on, take it off. And let's just stop that so you can see the traces. Now I'll just reverse that again, so let's restart, and then we'll do it with the negative terminal. I'm trying to do it as close to being the same as possible. So it's 1, that's on, and off, and on, and off, and on, and off, and on, and off. So I'll pause that. I think there's a little bit more instability just at the bottom. It's only a few millivolts. It's currently on 100 millivolts per division, so that's yeah, that's like probably about a millivolt or less. Okay, so let's increase the voltage to, let's just go 1 volt. I'll just have to hold this resistor down, I think, try and get a good connection. Okay, on, off, on, off, on, off, on, off, on, oops, off. That little squiggle there was me. So let's reverse the power, connect the negative, then I'll cycle through the positive. So on, off, on, off, on, off, on, off, on, off, on, off. Okay, let's increase the voltage to 10 volts. So the scope is on 2.5 volts per division. On, off, on, off, on, off, on, off, on, off. Okay, increase the voltage to 20 volts. Scope is on 5 volts per division. 20 volts. Resistor is starting to get a bit warm. On, off, on, off, on, off, on, off, on, off. Let's just do a slightly fast one, see if there's anything to capture. On, off. Okay, that's quite consistent. Let's just do the negative side. On, off. Right, I'm just going to change resistors here a bit because this is starting to get a bit hot. So we'll go to the 8 ohm resistor and we'll increase the voltage to 30 volts. On, off, on, off, on, off, on, off. And finally we'll go to maximum voltage. So we're on 36 volts. On, off, on, off, on, off, on, off, on, off. Okay, so that's the constant voltage is done. We'll move on to the constant current. So I'll just let the power supply cool down a little bit. So in the second part of the video, I'm going to do some constant current plots. And at the request of a subscriber, I am going to start that with an LED. The idea is to see if the power supply can react fast enough in current limiting to not blow up an LED. I think I know the answer to this, but we'll give it a go anyway. So I've currently got the power supply set for 2 volts at 10 milliamp current limit. So we'll start and we'll just make sure the LED is working to start with. Okay, so the LED is working, so it's 2 volts and 10 milliamp current limit. So I'm going to leave the current limit where it is and increase the voltage 1 volt at a time. So we go up to 3 volts. All good. 4 volts. All good. 5 volts. And it looks as if the LED has failed. It's illuminating very briefly and then just going into current limit. In fact, it's now open circuit, appears to be. Yeah, so the LED has gone open circuit. We'll try that again, just with one more LED. Let's try a red one this time. Put the voltage back down to 2 volts. Okay, red LED is working. 10 milliamp current limit, so 3 volts, 3 volts, it's good. 4 volts, it's good. 5 volts, good. 6 volts, and it's gone short circuit by looks. So when I touch it, the current limit is going into current limit 10 milliamps and 0.43 volts. So let's just increase the current limit just to see if it has actually gone short circuit. So I'll put the current limit to 110 milliamps, and boom, yeah, it's pulling 110 milliamps. So the LED this time has gone short circuit. So as suspected, the power supply is not fast enough to current limit on an LED to stop it from blowing up. So next I'm going to do some current plots with load resistors. So we'll connect up this resistor here, and we'll put the voltage to start with on 5 volts, and I will start with let's go with 100 milliamps. Let's just see what that looks like. Okay, so 5 volts, 100 milliamp current limit. Power supply's tripped. REP fault. Yeah. Let's just really push it on tight as hard as I can. 1, 2, 3, 4, 5. Yeah, I think it's the overshoot is because of the connection that I'm making. Okay, so let's increase the current to 1 amp. Power supply's tripped again. Okay, so we're on 1 volt per division. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, let's go to 3 amps. 1, and then need to increase the voltage. So let's increase the voltage to 15 volts. Now on 2.5 volts per division. Slow the trace down a little bit. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, increase the current again to 5 amps. Now if we can get 5 amps, can we? No, let's increase the voltage again to 25 volts. Scope on 5 volts per division. Okay. 1. Power supply's tripped again. Da-dee-da. It's getting a bit painful. Okay, here we go. 1, 2, 3, 4, 5. And so let's go to maximum voltage 7 amps. 1, 2, 3, 4, 5. Again, I think the overshoot is just a bad connection. Do that again, try and make good connection. 1, 2, 3, 4, 5. Oh, that resistor's getting hot. Okay, and then we'll just go to maximum current, so I'm going to have to bring the other resistor in. So I'm just going to connect another 4 ohm resistor in parallel. 1, 2, 3, 4, 5, 6 for fun. I'll just do this plot 18 volts 8.2 amp current limit. These resistors are going to start getting quite warm, so I'll just do one of these. One, 2, 3, 4, 5. And just for fun, let's speed the trace up a little bit, see if we can just get one. Okay. So there you have it, all the plots for constant voltage and constant current on this power supply. Can't say that I've noticed anything really ugly with that. So in that respect, I think the power supply is probably okay, according to my tests anyway. So if you enjoyed this video, please subscribe to the channel. Check out the other videos on the channel, and just as a reminder, there are some other videos on this power supply. There's a review video and a supplementary, so this is the second supplementary video, and there will be soon coming a video looking into what actually overheats on this power supply as well. So with that being said, thanks very much for watching, and I'll see you in the next one.